In this video, we're going to talk about higher order derivatives and do a few examples. So if f of x is a function, the second derivative of f, denoted f double prime of x, is the derivative of f prime of x. That is, it is the derivative of the first derivative. Similarly, the third derivative, f triple prime of x, is the derivative of the second derivative, and so on. So the 16th derivative of f of x is the derivative of the 15th derivative of f of x. There's notation for this, different notation. So as we saw, the second derivative is f double prime of x, and it can also be written in a few different ways. So it can also be denoted d dx, the derivative with respect to x of f prime of x, or d dx of dy dx. Now remember that dy dx is just another way to write f prime of x, or it can be written the second derivative of y with respect to x in that way, d2y dx squared, and it can be written also as y prime. So those are all different ways to write the second derivative. Similarly, we could write the third derivative in all those different ways. Once we get up to, the fourth, the fifth derivative, we stop using the prime notation and start using like n in parentheses. So the nth derivative of x is denoted in each of those ways, f n in parentheses of x, the derivative with respect to x of f to the n minus 1 of x, and so on. So those are all different ways that we could write the nth derivative of x. So let's just do a couple examples. Let's find the first, second, and third derivative of each of those functions below. So our first function is f of x equals 3x squared minus 5 times the natural log of x plus 4 times the sine of x. And our second function, g of x, is the square root of x plus 2e to the x minus cosine of x plus 10x. So I encourage you to pause, grab a piece of paper, and try each of those out. Find the first, second, and third derivatives of each of those functions. All right, so for our first derivative of f of x, that's f prime of x is equal to derivative of 3 times x squared. We can use the constant multiple rule, and then the derivative of x squared is 2x. Minus 5, again constant multiple rule, the derivative of natural log of x is 1 over x, plus 4 times the derivative of sine x is cosine of x. And so we could simplify that to f prime of x, the first derivative, is equal to 6x minus 5 times 1 over x. We could also write that as 5 over x, but for now I'm going to write that as 5x to the negative 1. And the reason I'm choosing to write it that way is so that it's easier to take the next derivative using the power rule, plus 4 cosine of x. All right, now let's take the second derivative. So our second derivative, f double prime of x, is equal to derivative of 6x is just 6 minus 5 times, so minus 5 times, now using the power rule, negative 1, bringing that exponent down, x to the negative 1 minus 1 is negative 2, plus 4 times the derivative of cosine x is negative sine of x. And now I can simplify that. F double prime of x is equal to 6 minus a negative 5, so plus 5x to the negative 2 minus 4 sine of x. If I wanted, I could rewrite that as 6 plus 5 over x squared minus 4 sine of x. But I'm actually going to, use it in that previous form again to be able to find the third derivative using the power rule. So now f triple prime of x, or that could also be written as f third derivative of x, is now equal to derivative of 6, that's a constant, so the derivative of a constant is 0, plus 5 times the derivative of x to the negative 2 is negative 2 times x to the negative 3. Bring down the exponent, subtract 1 from the exponent, minus derivative of 4 sine of x is 4, and then derivative of sine of x is cosine of x. And so this could be simplified as f triple prime of x, the third derivative, is equal to 5 times 0 just goes away. 5 times negative 2 is negative 10x to the negative 3 minus 4 cosine of x. And if we wish, we could rewrite that as negative 10 over x cubed minus 4 cosine x. So we've got our third derivative, our second derivative, and our first derivative. All right, our second example, g of x is the square root of x plus 2e to the x minus cosine of x plus 10x. I'm going to rewrite g of x as x to the 1/2 is equivalent to square root of x plus 2e to the x minus cosine of x plus 10x. And the reason that I'm rewriting that is so that it's easier to take the derivative using the power rule of square root of x, which is equivalent to x to the 1/2. So g prime of x, the first derivative, is equal to, using the power rule, 1/2 x to the negative 1/2 plus 2 times the derivative of e to the x is just e to the x, minus the derivative of cosine of x is negative sine of x, plus the derivative of 10x is just 10. We can either see that using the power rule, this is a 1 right there, or the fact that derivative of any linear function is just its slope, the m in front of mx plus b. So now we can simplify that. G prime of x is equal to 1/2 x to the negative 1/2 plus 2e to the x minus a negative, so plus sine of x plus 10. If we wished, we could rewrite that as 1/2 x to the negative 1/2 is the same thing as 1 over 2 square root x. That x to the negative 1/2 is the same as 1 over x to the 1/2, which is 1 over square root of x, plus 2e to the x plus sine x plus 10. So that's an equivalent way of writing that first derivative, but I'm actually glad that it's in that original form with that x to the negative 1/2, because that makes it easier to find the second derivative using the power rule. So g double prime of x, the second derivative, is constant multiple 1/2 times, using the power rule, negative 1/2, bringing down that exponent, x to the negative 1/2 minus 1. So negative 1/2 minus 1 is negative 2 over 2 minus, or negative 1/2 minus 2 over 2, that's negative 3/2. Plus derivative of 2e to the x is just 2 times the derivative of e to the x, plus derivative of sine of x is cosine of x, plus derivative of 10 is just 0 because 10 is a constant. So again, we can rewrite that if we wish. So yeah, let's do that. Let's simplify it. G double prime of x is equal to 1/2 times negative 1/2, that's negative 1/4 x to the negative 3/2 plus 2e to the x plus cosine of x. And finally, we can take the third derivative. So our third derivative, g triple prime of x, is equal to negative 1/4 times, bringing down the exponent, negative 3/2 x to the negative 5/2. We're subtracting 1 from negative 3/2, gives us negative 5/2, plus derivative of 2e to the x is just 2e to the x, plus the derivative of cosine of x is negative sine of x. And so we could rewrite that as g triple prime of x is equal to negative times a negative, that's a positive, 1/4 times 3/2 is 3/8, x to the negative 5/2 plus 2e to the x minus sine of x, and we could leave it like that. We could also write it as 3 over 8 times the square root of x to the fifth. So that negative flips it down into the denominator. The fifth is just the exponent, and the fractional, if we have a fractional exponent, the value in the denominator is really a root. So we can write it like that, plus 2e to the x minus sine of x.